So, hello everyone. So, in the last session, we have discussed model question paper solutions for the your third subject of BEC 303 Electronic Principles and Circuits. So, in today's session, we are going to continue with those problems only. Okay. So, here our first question here is 5A till 4C we have discussed, right? Yeah. So 5A question is with the neat circuit diagram, explain the operation of R to R digital to analog converter. Okay. R to R ladder digital to analog converter. So these are all the explanation points that you need to be uh, knowing, that is it overcomes the limitation of binary weighted D to A converter and R to R figure shown as 4-bit D to A converters. The switches are from D0 to D3 and the switches connect 4 inputs to either ground or logic 0 or V reference, that is reference voltage logic 1. The MSB bit is connected to the inverting input terminal and the LSB bit is connected to the inverting output terminal here. So this is the circuit diagram that you need to be knowing for R to R digital to analog converter. So we will be having R1, R2, R3, R4, R5, these five resistors in parallel, along with R6, R7, R8 with the in shunt connections with all of these. Along this, we would be having the diode switches where the closed switch corresponds to the value of this would be 0 and this open switch corresponds to the value of the weighted converter would be 1. Okay. Yeah. To determine this D to A converter, this is the standard formula that you need to be knowing. Okay. Then the output voltage would be determined by B in. So these are the terms we need to be writing it for this. Okay, so this was all about the R to R D to A converter. Okay, if you want, you can pause the video and refer this. So now we'll go to the next question, 5B. For the circuit diagram, with the input voltage is a sine wave with a peak value of 10 volt. We need to determine the trip point and also plot the input and output waveforms. Okay, so this is your question. So this is the circuit diagram that is given in a question. Okay. So here we can see that the input wave is sine wave as given in the question. We need to plot the input output wave. First, we need to know the value for reference voltage here, and given parameters are R1 and R2 are given right here. Yes, that is 100 kilo ohm and 200 kilo ohm. R1 is 200 and R2 is 100. Then substitute that, we get the reference voltage equal to 5 volt. After that, the figure shows that the input sine wave has a peak value of 10 volt. The rectangular output has a peak value of approximately 15 volt. Then draw the required input output waveform, that is sine wave as well as square wave. Okay, we get the input wave is sine wave and the output here we got it here as square wave. Okay, yeah. So now we'll get to the next question. The next question here is with a neat circuit diagram, explain the operation of a Schmidt trigger. Okay. Yeah, so this is the explanation you need to write for Schmidt trigger. First, write the basic how this Schmidt trigger works. Okay. After that, again draw the circuit diagram here of the Schmidt trigger. That is the non-inverting inverting terminal is grounded and non-inverting terminal is grounded along with the two of the resistors in shunt. Okay, this is the standard value for beta, and these are the upper trigger point and lower trigger point. That is beta into V saturation and minus beta into V saturation, and this H stands for hysteresis. Okay, this H stands for your hysteresis. That is the summation of UTP plus LTP would give you 2 into beta V saturation. So this is your hysteresis plot. Okay. This is very very important. You need to draw this. Okay. Then we need to explain this curve. That how this curve comes. That is we need to explain this whole thing. Okay. Yeah. So that's all for Schmidt trigger again. And again, we need to explain these expressions as well. Then the same thing here, how the value of upper trigger point comes, lower trip point, upper trip point. These are all the key points that you need to mention it. So yeah, these and all are the values for output voltage, input voltage and all. How this beta plus beta V saturation would come, minus beta V saturation would come, and the output switches would be from negative to positive. When the output is negatively saturated, the reference voltage is lower trigger point, and when the output is positively saturated, the reference voltage is corresponding to the higher trigger point. Okay, and the hysteresis is the summation of those two. So that's all for this Schmidt trigger. Please note that this is an important question. So you will get to the next question, that is, with the need diagram, explain the internal diagram of triple five timer and waveforms of the operation of the A-stable multivibrator. Okay. So first again, the A-stable multivibrator, write all the explanations required. Along with that, draw the necessary circuit and the expressions as well. And after that, draw the internal structure of this A-stable multivibrator using the triple five timer here. Okay. So we have here all the pin numbers. You can mention that pin 1 is given, pin 2 is given, pin 3 is output, and pin 4 is grounded, I guess. Pin 6 is threshold, pin 7 is discharge, and pin 8 is supply voltage. So these in this way we need to draw the internal structure as well, along with the necessary waveforms here. Okay, and also explain few of the terms. Okay, so that's all. So in the next question, 6b, with the need diagram, explain the operation of Wien bridge oscillator. Okay. So again, we need to draw the basic circuit diagram of this Wien bridge oscillator here now. So this is the circuit diagram of a Wien bridge oscillator. It consists of a resistor and capacitor in series, and all these in a bridge together. Four resistors and along with the capacitors in shunt. After that, we need to draw with these two terminals connected to an op amp and measure the output voltage and explain these things. These and all are the things that you can pause the video and refer it. This is the frequency, resonant frequency in case of a Wien bridge oscillator, that is given as 1 by 2 pi RC. Okay. Also, we have few of the important concepts here from module 3, op amp and oscillators. So, op amp and oscillators, the first thing that we need to know, that basic things are, we need to write the ideal characteristics of op amp. Also, we need to be knowing the expression for inverting and non-inverting configuration, and also we need to know slew rate, CMRR, PSRR, all these definitions and all. They might ask as a sub question, okay, in the exam, and write a small signal equivalent circuit and also for a two input summing amplifier. Okay, and these and all are the stuff, a few of the important problems. We have discussed R to R digital to analog converter, right? So now we have one more concept, that is binary weighted digital to analog converter. This is the concept here. You need to be knowing. Okay, please make a note of this and read these things. Yeah, so that's all for this third module here. So these and all are the problems related to that. Then this is very very important. Op amp as comparator. Okay, comparators with zero reference, non-zero reference, inverting comparators. Please pause the video and refer it down. All the waveforms are very very important here. Okay, and also the Schmidt trigger we have discussed here. See, hysteresis plot and all, and oscillators. So this lead lag circuit is very very important. Okay, this lag circuit expressions, lead circuit expressions. Okay, wherever I am putting a circle, it means that those are important ones. You need to learn those. Okay. Then we have phase shift oscillator, Colpitt's oscillator. Okay. Then we have another one kind of oscillator, that is Hartley oscillator. Those are and all are very very important. You need to be knowing these things. Okay. Okay. So that's all. So now we'll get to the next question, that is 7a, that is the fourth module. Okay. The given question is, we need to classify the negative feedback amplifiers and explain each with a neat block diagram. Okay. So first write the four types of negative feedback. That is, we have it as a voltage control voltage source, current control voltage source, voltage control current source, and current control current source. These are the four negative feedback amplifiers. And draw a block for this separately for all these things: VCVS, ICVS, VCIS, and ICIS, with all the sampling and mixing side. So here in this VCVS, the sampling and mixing side, the resistors and the current are in shunt. In ICVS, it's in series. In VCIS, it's in series in the mixing side and parallel in the sampling side. And here there are in series in the both mixing and sampling. Okay, ICIS. Then explain all kinds of the amplifiers, all four negative feedback amplifiers. Explain this. See if this is for VCVS, ICVS, VCIS, and ICIS. You need to explain these all things. Okay. Yeah. So the next question here is we need to calculate the feedback fraction of ideal closed loop gain, percentage error, and exact closed loop voltage gain using the value of over loop gain as 1 lakh for a IC741. Okay, this is the given circuit. So first, the first thing we need to calculate here is the feedback fraction beta. This is not B, okay? This is beta. Beta is given as R1 divided by R1 plus R2. Substitute the values for R1, R2. We get it as 0.025. After that, find the value for AV, 1 divided by beta. We get 14 as your ideal closed loop gain. Percentage error is given as 100% divided by 1 plus a open loop gain into beta, that is 100% divided by 1 plus 1 lakh into beta. We got it as 0.025. We get it as 0.04 percentage. Okay, so these are the other parameters and all we need to calculate. This is your final answer actually, but these are the other parameters. So you can pause the video and refer for this solution. This is the answer for 7b here. Also, we have a 7C question here with the need circuit diagram and expressions. We need to explain all the current amplifiers. So the current amplifiers corresponds to an ICIS circuit amplifies the input current. Because of the heavy negative feedback, the ICIS amplifier tends to act like a perfect current amplifier. It has a very low impedance along with a very high output impedance. Okay, so the ICIS current amplifier corresponds to a very low input impedance, and also it has a very high output impedance. So this is the circuit diagram. After that, write all the necessary expressions. Pause the video and refer it if you want. Yeah, so that's all. So now we have a 8A question, that is we need to classify the filters and explain the ideal response for each of the filters. So we need to classify the filters into many types. That is, the first type is low pass filter. Then we have a band pass filter. We have high pass filter and all the necessary expressions, and pass band and stop band regions and all we need to mention it. Okay, and also the few of the expressions for f naught bandwidth. Here the expression for bandwidth is given as f2 minus f1, that is higher cutoff frequency minus the lower cutoff frequency of a particular bandwidth. Okay, then the q stands for quality factor, that is f naught is corresponds to the product of the higher and lower cutoff frequency along with its root. Okay, and this q is given by f naught divided by bandwidth. Okay, and also we have one more kind of filter, that is band stop filter, and also the fifth type is all pass filter. These are the things you need to be explaining. You can pause the video and refer for all the explanations. So we have 8A is done. So now let's go to 8B. With the neat circuit diagram, explain the operation for first order low pass filter and first order high pass filter. Again, for low pass filter, again write all the necessary circuits. That is, we need to write the RC lag circuit for low pass filter. In case of non-inverting gain, and in case of non-inverting with the voltage gain, write the circuit as two additional resistors in shunt along with the resistor and capacitor, that is for output input voltage side, and this is the output voltage side. Write all the necessary equations, and inverting with the voltage gain, this is the circuit. And also for high pass filter, again the same thing, non-inverting unity gain, non-inverting with voltage gain. Write all the expressions again. Pause the video and refer it. These all points are, you need not be writing all these points. You can write it in short points. That circuits and expressions are very very important. First, make a note of those things. All the expressions and circuits are there, right? Those things are very very important. Wherever I'm marking right, those things at all you need to write it in your exam. Okay, yeah, so that's all. So also in module 4 we have few of the important other stuff that we need to be discussed. That is here in module 4, the ideal negative feedback. four types. And also we have a block for this feedback amplifier. This is very very important block of feedback amplifier block would be like this. Okay, the source, after that the block, feedback block, along with that it consists of an amplifier, input and output signal, along with load, source, again the amplifier block, amplifier, input and output signal along with the load. This is the first half of the block consists of a positive feedback, and the second half of the block consists of a negative feedback. Okay, you need to be knowing this. And now we'll discuss the last module of this model question paper, that is the fifth module. So here in the fifth module, the first question is, with a neat circuit diagram and a waveform, explain the SCR phase control using RC circuits. That corresponds to an RC firing circuit. Okay, again draw the circuit diagram and all the waveforms and these explanations. A few of the important points are enough. You need not be writing all of them. So this much you can write. And when R1 increases, what would be the phase angle and all? Mention those things. And after that, the angle between SCR fires is called as firing angle. Mention that. These things you need to mention. The conduction angle you need to mention. Okay. Then yeah, these are the important points that you need to be writing for this RC phase angle circuit or RC firing circuit. Okay. So the next question is, with the neat circuit diagram, explain the operation for UJT and then explain how it is a relaxation oscillator. So UJT stands for a uni-junction transistor. Okay, this UJT stands for uni-junction transistor. It has two doped region as shown in the figure. The two doped region are positive doped and negative doped here. So these are the necessary circuit diagram along with the symbol of a MOSFET. Okay, yeah, then write the necessary explanation, and after that how it is used as a relaxation transistor. Okay, for that we need to be adding few of the resistances in series and also write the input waveforms. So this is a spike waveform here, and write all the necessary explanations. All points are not required. Okay, so now we'll get to the next question, that is 10a. 10a, make use of a breakover characteristic to explain the operation for four layer diode breakover characteristic. Okay, so yeah, this is the graph that you need to be knowing. So this question is not so important. I guess this is not there in the syllabus as well. Okay. Yes. If you want, you can refer this by pausing the video. So the next question is very very important. That is, we need to write a short note on IGBT. So IGBT stands for Insulated Gate Bipolar Junction Transistor. Okay. For that, you need to be knowing MOSFETs as well as BJTs very clearly. If you know those things, we can write the explanations for these insulated gate bipolar junction transistor. That is, we need to be explaining both the MOSFETs as well as the BJTs, bipolar junction transistors. Okay, so write these points first. After that, write the MOSFET structure, that is for N-channel MOSFET, along with few of the symbols. Okay, and the last question is, we need to explain the bidirectional thyristors in brief. So again, these are the few of the explanations for bidirectional thyristors here. You can write it down. And this is the circuit block of this bidirectional thyristor, which is used as a DIAC. Also, using a TRIAC, you can explain the bidirectional thyristors. This is a very very important question. Please make a note of these bidirectional thyristors. Yeah. So that's all. Hope you like this. So if you are satisfied with these answers, please comment down in the below, so that we will be providing more stuffs related to the upcoming exams. So in the model question paper, what and all are the questions are there? We have tried to cover all of them. If you want, you can pause the video and refer all the answers, and you need not to be writing all the points. Few of the key points that I have highlighted, along with the circles that I have mentioned, all the circuits, expressions, and all are very very important. and related to that circuit itself we can explain all the other points. Okay. Yeah, so we have covered two videos of regarding of to this model question paper part. So we have discussed all the solutions. If you have liked this, please share it to a huge number so that the other people would get the answers, and the other people would find it easy. So that's all for this session. In the upcoming sessions, we would be getting you the other subjects, model question paper solutions and all. So till that, all the best for the exam from my side. Please, everyone, do well. Practice these questions and also some of the additional questions if you want. I have created a short in this channel itself. You can refer it down. Okay. So yeah, that's all. Thank you.